Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Jeremy McCullough, a senior product engineer with our electronics group, and we'll be discussing functional safety. Hey, Jeremy, thanks so much for joining us today. How are you?
I'm good. How are you?
Doing well. So today we're going to talk a little bit about functional safety and kind of how SEW is involved in that world. So let's just start off with a kind of overarching idea of like, what is functional safety?
Sure. So functional safety, it's basically, to put it simply, is it's safety that's part of the control system. An example of this would be, so if you've been in a factory or plant, you're probably used to seeing safeguarding like fences, doors, things like that. That would be an example of passive safety. It doesn't really have to do anything other than just be there and, present like an obstacle or barrier from somebody accessing some sort of motion that would be hazardous. But what functional safety is it's a little bit more active than that. So if you think about an example I like to use is an emergency stop button. You see one by the machine. Whenever you press it, what you expect to have happen is the machine comes to a stop. But for that actually to happen, and for the machine actually to stop, several things have to happen, and they have to happen correctly or properly, basically. You have to press the button. Something has to detect that you press that button, and then something has to tell the machine to stop, and then the machine actually has to stop. And so from input to output, that entire chain, everything has to work properly in order for that safety function, which would be, the emergency stop would be the safety function, in order to work properly.
Right. So it's just kind of the whole control unit. It's not something that just stops you from engaging with a machine. It's actually stopping the machine safely and everything involved from the input to the actual ending of the process.
Yeah, it's active safety, basically. So whenever a certain event or condition happens, it has to detect that and has to respond appropriately.
So how would that compare, like maybe in the everyday world, how would a functional safety event be different from like a standard event?
Sure. So, when you're dealing with like control systems automation, you might wonder, okay, what makes the safety system different from the standard system? So one example would be, you have a button that does something. It's not going to have the same level of redundancy and checks and things. And I guess maybe more a common example that I like to use is, whenever I grew up in elementary school, you'd hear about the space shuttle and everything. That was like really cool back then. And one fact that I always remember that always stuck out was that they said that it has 3 computers on there for redundancy. So if one failed, then the other one could take over. But if I compare, for example, my own self, and probably you as well, my laptop that I use at home, I just have one of those.
Right.
And the reason is, like, if that ever broke or failed, I could take it in for repair, or I could just go get another one if I needed to. If you're up in space, then you don't really have that option. So it's really all about doing what's appropriate for the level of risk and considering what could happen if there was a failure. And so for safety devices, you're going to have more levels of redundancy, more checks, diagnostics, things like that, that make it appropriate to mitigate risk.
So it just depends on the severity of whatever you're dealing with on how safe you need the environment to be. So like
Exactly.
at my house, no big deal if I lose a laptop. If you only have one on a space shuttle, that's going to be pretty catastrophic.
Mm-hmm.
So we got a pretty good overarching idea of what functional safety is. So how does SEW-EURODRIVE fit into the world of functional safety?
Sure. So, from our slogan, driving the world, right? We make things move. That movement is a good thing. In some cases, it can present a hazard to people or, other machines or the environment. And what functional safety is concerned with is basically making sure that the risk is minimized, the risk associated with that. And so we offer an entire product portfolio, products and services that basically allow users to implement whatever functional safety they may need. And so a few examples of that. So if you buy a VFD or an inverter from us, that's probably going to have safe torque off, which is basically just a way of making sure that when the machine's not supposed to move, the motor's not going to produce torque. That's a very common safety function, probably the most common one that we offer. Stepping up a level from that would be safe monitoring. So what we can actually do is if you order the motor with a safety rated encoder, you can have that go into our inverter that has a safety card. And if the machine goes over a certain speed, then it can shut it down and make sure that it doesn't present an additional hazard. And an example of, I guess more of a practical example of that is, let's say that you have some sort of a machine and then you have a fence around it. And normally nobody really needs to go in there to access it, but maybe somebody has to go in for maintenance. They have to change parts, whatever that may be. Maybe you don't want to stop the machine while that happens. Maybe you just want to slow it down so that your process keeps running.
Right.
But at the same time, it's slower. So if someone walks in there, it doesn't do anything that's unexpected. And even if it does, they can step out of the way. It also reduces the forces associated with it. And that would be an example of what functional safety technology allows you to do now with all of the nice features that drives and inverters have. And then another example of a safety function that we offer is it's associated with our brakes.
Okay.
So probably most of the motors that we make are going to have some form of a brake on it, and which that's great. That's something we've done for many years. But now, if you have that brake that's performing something that's critical to the safety of the machine. So, for example, you have a hoist or something that somebody is standing on a platform.
Right.
You don't want that. If that brake is the only thing that's holding that platform in place, you want to think about what happens if it were to fail. Like,
Right.
You don't want that to cause hazards. And so we have a safe brake system that if you size everything and implement the proper external diagnostics, you can actually use that motor brake as a safety brake, essentially.
So what I'm hearing is we have a lot of options and a large portfolio that can fit the custom needs of our customers. And we're also giving them more options than for this application to be safe. It cannot move. It sounds like we're giving them accessibility to either slow it down or control it in just very certain types of actions, like a light curtain or something being broken. And then they can still actually move or process in some of the circumstances, and not necessarily, if it's not safe, it has to stop moving.
Yeah, exactly. So, you mentioned like a variety of different cases. So our customers, their needs, they're wide, they're varied. It doesn't just have to be safety, but it's just with our portfolio in general. If customer has something that they want to do, we have a solution for it. So, for that, we would encourage them to reach out, and then we can guide them towards whatever solution we would have for that.
Well, that is awesome. And if anyone is interested, they have a local sales rep, and then they can always call in any of our plant lines and ask for engineering support, and they can get to the right people. Is there anything else you want to talk about functional safety, or have we about covered the 10,000-foot view?
Yeah, certainly 10,000-foot view, maybe a 30,000-foot view. But I would say if customers have any questions or they want to find out more, just reach out and we'll see what we can do for them.
Well, fantastic. Thank you so much for coming on today.
Okay. Thanks, Cully.